Hey there. So this time I'm bringing a very different project here. So with the recent advances of generative AI, both for text, video, audio, and all the other domains, something that has been quite exciting for me is the potential for these new advances for content creation, mainly for personalized content creation. So with the recent models of Imagen, Stable Diffusion models, and those kinds of models, as well as the video models, content creators has been improving a lot. Now it's much easier to create all kinds of assets and speed up and make the whole workflow more optimized. And now that we have more agent frameworks that are also more mature with these new models, with the new requirements from the users, it's also easier to integrate those models into a complex agent framework. So with this in mind, I created this project here that I called Neural Reels, which is a AI-powered short video generator. So it will be creating those videos for YouTube Shorts, Instagram Reels, and that kind of short content. But before we dive into the actual code or example, I will show you what the final result looks like so you can have an idea what we will be creating. So this is one of the videos that I generated here, and it's a short video about the rise and fall of Rome. So I will just play a few seconds here for you to have an idea.
Rome, founded by twins Romulus and Remus. What began as a myth grew into an unstoppable force. Overthrowing kings, Rome founded a republic, a revolutionary system of elected officials. Through disciplined legions and epic clashes like the Punic Wars against Carthage, Rome expanded relentlessly, dominating the Mediterranean. But growth brought internal strife. Civil wars tore the republic apart until Julius Caesar's rise and fall paved the way for his heir, Octavian. As Augustus
Okay, so I think you can have an idea here. So everything that you are seeing here was created by agents. And the reason that the video has this format is because I created optimized for, let's say, vertical cell phone visualization. Like it's most of the short content creations. This is customizable, but in this case, I'm only creating like this. So you can see that basically you have a script for the content that will be created. You have the voiceovers. I chose specifically this one, but it's customizable, so you can have any kinds of voices that are available for this specific model that I will show. I also created the images. I added some animations to the image, and I have also created some videos here. So, and everything is joined together in a specific way so that you can have this final video at the end. Okay, so let's go here. So if I go back, and by the way, this is in a GitHub repository, Neural Reels, so you can take a look later. I have a README page here that is quite complete with all the explanation of how it works, a few examples, how to get started, how you can use it, and a few more descriptions here. But I also have this nice diagram here that explains the workflow and how it works. So I will go back to the code to just give a few information before I actually launch it, and we can take a look in practice how it looks like. So the main agent here is this one in the main page. So the agent file, which is this final one, the video creator workflow agent. So the idea of this agent is that it will be like the orchestrator or the main agent of the whole system here. And if I go back here by the end, you can see that it's a base agent. So also, as you saw from the previous image, I'm using ADK here. So this is the Google's framework that was launched earlier this year. So it's quite good, and I have been playing a lot and making a lot of experiments. This is the most complex project that I have done so far. So I had the chance to do a lot of very cool things and explore the limits and the flexibility of this framework. So far, I have been enjoying a lot. So going back to the agent that I'm using this base agent here. You can think of ADK, at least this is the way that I like to think about it, is that it's more like an agent-focused framework. Might be a little bit more similar to maybe Crew AI, but if you think about something like LangGraph, which is like a workflow and graph-oriented framework, this is a little bit different. So the main components that you have, they would be agents, and you need to structure your workflow your pipeline, thinking on everything like agents. So ADK, it provides a few agents, the basic one, which is the most simpler, but it also provides a few different agents. So these workflow agents, which is the sequential agents, which is basically a sequence of agents chained together, loop agents that can do a loop, and the parallel agents if you want to execute agents in parallel. The reason that I'm using the custom agent is because I am building a specific workflow that has a very complex logic. So I will be doing different things, calling and triggering different functions, tools, or agents, depending on the execution and outcome of the specific agents, but also mainly on depending on the prompt input feedback of the user. And you can see how it looks like. So this is the main reason that I'm using this specific agent here. So if I go back, you can see the diagram here, and it has three main stages: the theme definition, script refinement, and finally the video creation, which is the bulk of the work. And you can see here at the code, if I go to this main function of the agent, which is run async implementation. So this is basically, let's say, the action, the execution of the agent for ADK. And what I have implemented here is basically what you can see in the diagram. So it's a little bit more complex and tricky to look here. You can maybe take your time and take a look at the repository to understand it. But basically what you will see here is this execution, which is an interaction with the user. So there are many ways to run ADK using the command line web interface that they provide. But for this specific example, I have created a Streamlit front end, which I will run now, so it's much easier for we to understand what's going on. So let me go back here. I will open my terminal, and I will launch both components of my workflow, the front end and also the back end. So you can see at the front end page that I have a single file, which is basically the Streamlit front end. It's very simple. I have created using Gemini and also Code Assist. So it's a little bit of vibe coding here. So it's maybe simpler than what it should be, but works really well for this case. So what I will do here is that I have a few makefile commands here that will trigger some specific actions. So in this case, I want to run the backend. Let's start it here. And I also want to start my front end. So this is already running. And it will open the page. Okay, so I have here the front end page. So I will run the execution and I will explain what's going on step by step. So this is the main one, and I have the chat here now that I have initiated my session, and I can start prompting with the agent. So a video that I would like to create, something that I think it's a very cool story, is the 6 labors of Hercules. So this is a very famous epic tale of Greek history, which discusses about the 6 jobs, works that Hercules has to do. So I think that, especially because of the video, this will do a very good short video. So let's see how it goes. I can write any kind of prompt here, but it's like kind of a chat. So let's create a video about the 6 first labors of Hercules. So this will be sent to the first agent, and also then it almost immediately gets the feedback. Okay, so this is the output, and then we can go to the diagram. So if we go to the diagram, we can see basically this first interaction, which is the theme definition. So the user provides a prompt, a description of what the kind of content that wants to create. We have the theme definer that defines the theme and intent of the user based on the input, which is this here. So the theme and also the user intent. Okay. And then we have the user feedback. So based on what was created by this agent, it asks the feedback from the user. So it's actually prompting the user to approve or disapprove. So it's saying here, it seems that you want to create a short video content about Hercules labors. Is this correct? Answer yes. So yeah, I could just iterate a little bit more, so give more information about what kind of content I want to create. If I change idea, I can also talk a little bit with the agent here, but this is very accurate. So I can say yes, or I can say anything else because an agent will be processing this. So I can say looks good. The user feedback agent will receive that that input. It will process, it will see that I approved, and it will go to the next step, which is the script refinement. But before we go into these details, let's go back into the code and see what's happening, at least with these two first agents. Okay, so let me move this a little bit, this as well. And I can go here to the initial step of the workflow. So again, this is a base agent. That is why it has a custom logic inside of the execution. So the first execution is this one, which defines the theme and asks for feedback, which is basically a helper function that runs one of the sub-agents, which is the theme definer, and then it will also run next the user feedback agent. So they are very, very similar, but let's look first into the theme definer. Actually, I can go here. So in the agent, the theme definer, this agent here. So I can see basically all the code relevant to this model. So I'm using Gemini Flash because it's executing a simple task, and I want it to be very cost efficient, also be fast. You can take a look at the prompt later in more details, but it's something very basic just to guide the model work. And this is how I define my agent. So you can see that I add a name to the agent, a description, the instruction, which is the prompt, model ID, which is Gemini Flash, and this output key is on the session state of the whole workflow where the output of this agent will be stored. So it's basically a dictionary, and in the key of the theme intent, I will be storing the output of this agent. In this case, because I want it to be structured in a very specific way, I'm adding the output schema, which is a Pydantic basic model. So it will basically be a dictionary with the theme and user intent, which is what you saw. So if I maybe go back here and go to the output of this agent, it's a dictionary, right? With theme and user intent, which is what you saw here. The other agent, which is the script writer, is very, very similar to this one. So same model, also a script here, and the agent definition here. So I have most of the same fields. In this one, it has a specific callback and also this specific flag, so that it doesn't, let's say, this agent doesn't process. This agent won't have the input, which is the whole chat history before it. So it's just a way to make it more efficient. If I had a very long history, chat history with the model, this agent will be, let's say, processing a lot of input tokens. With this, I'm only giving this specific prompt here, which has the theme, which is the relevant part for it. In this one, it has something a little bit different, which is the agent after agent callback, and it's a custom function. So ADK allows me to write specific callbacks, or even use the custom ones, the built-in ones, which is basically ways to have functions that will be executed on specific steps of the agent execution. In this case, it's after agent callback. So after the agent is executed, this callback will be run. So if I open it here, you can take a look. So what it does. So save agent output. Basically what it does here is that it will get the session state of the current execution. It will iterate over this session state, which is basic a dictionary, and it will save everything that is part of the state. So I can show you what it looks like. If I go to the project here and I go to maybe Roman Empire, which is the previous one, you can see that it has a lot of outputs here. And if I go to the theme intent, so you can see the theme and the user intent, also the script, I can see the script here. So basically, every time that an agent is executed with this callback, it will save the whole session state until this agent. I can use callbacks in very specific ways after the agent is called, before the agent called, after the LLM, or before the LLM is called. In this case, I want it after the agent because I want to save the state after the agent updates the state. But this agent is very simple as well. So we can actually go back to the code and see what it did. So if we go back to the diagram here, after the user approves the theme, it will launch the research step inside the script refinement. So I have given the theme of what I want to create. So I do have two agents that run. The expert agent, which is basically LLM that will create a report from the theme that I want. In this case, it was the 6 labors of Hercules. And this is like a larger version of Gemini. So Gemini Pro, we create a report about this theme. But I also have another agent here that will do a web search to build a report also on the theme. And since I have a lot of information, I also added here a research compiler, which will receive the input of both of those agents, create a compiled research report based on information, and this report will be tailored for the next agent that will actually write the script. So let's first take a look at what they generated so you can have an idea. So the first one is the expert report. So a larger version of Gemini created this report here. So you can see it describing the first labor, second labor, all of them. Then it ran the web research. And I can see here also the research from the web agent created here. And then it ran the research compiler. So it took all the content generated by the other two research agents and compiled into a more digestible report that will be used for content creation. Okay, so those two agents, they are also very simple. They are part of the workflow. A little bit down, so we actually start in the second stage here in the script refinement. But I will open the two agents so you can see. So the expert agent is very similar, so a basic agent similar to the previous one, but this one is using Gemini Pro since I wanted a more capable model that will actually be able to have enough knowledge to create that detailed report that I want about basically any kind of theme. Gemini can do this very well, especially the Pro version. If I go to the web research agent, this one is also interesting because it's a little bit different. So this one uses also Gemini Flash, has a basic prompt here. But what's different is that it's using a specific tool, which is Google search. So you can see that this is not a tool that I have implemented. Google ADK already provides me with this tool. It's a built-in tool, which does Google searches. So it's very intuitive. So this is an agent that I can just pass this tool, and anytime that I call it, if it thinks that it's ideal for it to use this tool, it will run web searches to fulfill its goals. So the way that it uses is that I need to prompt it in a specific way or describe the agent prompt in a specific way that will understand that it has the tool available, which is you can see here. It will execute, get the result, and then pass the output, in this case here, for the web research report. If I go here and I see web research report, I can see the output of this agent, so which is a markdown file. Okay, so we can go back to the application and we will go to the next step. So after we have the research, we will call the script writer. So it get that we compiled all the compiled information. It will create a script for this specific theme, the video that I want. And it will also prompt the user for approval on the current iteration of the script. So if I go a little bit down, I can see the script, which is this one. So you can see that I already have an issue here. Sometimes it happens because both of the agents, they create a lot of content. So also the compiled version of the report also has a lot of information. So sometimes the script is a little bit long and I want to create it because it will be like, I don't know, 5 or 6 minutes long. So I will just prompt the script writer here to make it a little bit smaller. Make it a little bit smaller. Keep the main ideas, or maybe the main points of each label. So you can see that I'm not giving explicit approval or, let's say, disapproval of the script. I'm just providing some feedback. So because it's an agent that is receiving this input, it understands that I have not approved since I gave feedback, and we will iterate a little bit over the script. Okay, so yeah, you can see that feedback here, the user feedback agent, it digested my input to this, it passed that input to the script writer, and the script writer refined the script a little bit. So yeah, maybe it's good enough. I think it's still going to be a little bit long, but I think that it gives the idea. We can see the final result. So okay, it looks good now, and it will see that I have approved the script, and it will go to the next step, which we can see here. So after the script is approved, it will start the bulk of the work, which is the actually creation of the assets. So another agent will take this script and it will break down into scenes. Basically, probably in this case, each scene will be one of the labels or something very close to this. Depends on how the agent will do it. I can show you this agent, how it looks like, but after it breaks down into scenes, I will have two agents which will create the prompt for the assets. So we will be creating the visual assets, which are images and videos, but a very efficient way, maybe a more efficient way, will be to create efficient prompts for images and video generation. So I can just describe what I want or get the scenes and ask for image or video of it. But if I first have an agent which is powered by Gemini to get the scene and create a specific prompt that is tailored for each one of the scenes, I will have like a better result. So I have the image generator, the image prompt generator, and video prompt generators to create images and video prompts. Then I have the image generator and video generator, which it will take each prompt for each scene and generate the images and videos. Then I have the video assembler, which will take the videos and images generated and assemble into the final video. Actually, I missed here. And I also have the voiceover agent, which will take the text from each scene and generate voiceover for it. And this is also powered by, this agent is also powered by Gemini, which is a text-to-speech version of Gemini. Then I have the final video assembler, which assembles that into a final video. And then I have finally the SEO optimizer, which will take the script from the that the user approved, this one that I just approved, and will generate the SEO assets, which is basically a suggestion for the video title, and also optimize the description for SEO, which have some hashtags and some specific wording to, let's say, amplify the range and reach of your content. So let's go into the actual code. So I can see that it's still executing here because this takes a little bit of time. Maybe it's going to take, I don't know, 2 or 3 minutes, something like this. Then we can come back later. But let's look into the agents. So the first agent after the execution, we can see here, it will be the scene breakdown agent, which takes the script and breaks into scene. And this one is also a very simple agent, similar to the previous ones that I have done. It has nothing special, just the specific prompt. After this scene breakdown agent, I will be running the image prompt generator and video prompt generator. They are very, very similar. And they also have, let's say, basically just a prompt and nothing special. You can see that each one of them has a specific schema for output, but it's similar to the other agents that I have shown. So this is the video prompt generator, also very similar. After we generate the scenes, the prompt, we run the voiceover generator. And this one is more interesting. So if I open it here, you can see that it's a little bit more complex. Similar to the main agent, the one that is the orchestrator, this one is also a custom agent. The reason is that the logic that I'm using here to create the audio, it's more complex than just calling a model API. I do several things with the voice to process it and to save in a specific way. So this is also the reason that I need a custom agent here. You can see that I use a specific version of Gemini, which is the Gemini 2.5 Flash, but the TTS version. So this model, differently from the regular one, I will prompt it with a text, and they will generate the audio of it. And I'm using this custom audio, custom voice here, but maybe later I will just do a random voice to change it every time. And I will just briefly show you what it looks like, because code is a little bit complex. I have this main function, which is generate audio, which basically takes the prompt, calls the model here using the generative AI API from Google, and then saves the audio into a specific folder. You can see here for the previous video, for the scene one, I have the voiceover here. So it also implements that same function, which is run async imp, which is the main execution function of all the agents, and I have a custom logic here. What it will do is that it will get the prompts, basically the scenes from the session state. It will iterate on each one of the scenes and generate the audio voiceover for each scene. So it's quite basic, but it requires a custom logic. That's why I'm using custom agent. Then after the voiceover, we have the image generator, which is also similar to this one. So it also has a complex specific logic. In this case, I'm using Imagen for the Ultra version to generate my images in that specific aspect ratio. So it's a vertical screen. It's also very similar. I have a generate image function here that calls the model and saves the output. Model calling is very simple with the Google framework, and then I save it here. So it's the same idea. I get each one of the scenes, the prompt for each one of the scenes, iterate over them, generate the image, and save them in a specific folder. In this case here, you can see the image that is generated. Finally, for the asset generation, I have the video generator, which follows a similar pattern. So you can see that I have this specific function, generate video, which calls the Google API, calls the model. By the way, I'm using the Vue version 2 here, especially because at this time, the Vue 3 version, it does not generate video in this is aspect ratio. So I just wanted to match. 8-second video, so some custom configurations here. So I have this function that calls the API. This requires a little bit more logic because video generator, video generation, it takes a little bit of time. So I need to keep checking if the operation was successful. Sometimes it takes a little bit longer and that fails. So maybe I need to generate more than one video just to be sure what happens here. And in the main function here, the agent execution, I have a similar thing. So I get all of the video prompts from the session state, I iterate over them, generate the video, and save them on each one of the scene folder. So in this case, you can see that in the scene one, I have the voiceover, the image, and also the video. And then when I have all of the assets for every scene, I will run the video assembler, which is, again, custom logic. So I need a custom agent, a video assembler, and it's this model here. So I have a few functions. This one is to apply a random effect on the images. So it's not just a still image, it's animated. So I have a few simple ones here, one that does nothing, zoom in and zoom in different, speeds. And I can also like reverse the speed, the effect. So instead of a zoom in, it's a zoom out. So basic stuff here, not a lot of logic. I have this one that assembles basically all the assets for a single scene, takes the voiceover. It's maybe a little bit complex logic. So if you take the time, you can see that it makes sense. It's kind of simple in some sense. The idea is basically that we'll take the audio duration and fill it with videos and images to make sure that it matches the duration of the audio. After doing this, you can also see finally here the main function, the agent execution, which is very similar to the other ones. It will take all of the scenes, sort them, and iteratively assemble the clip for each one of the scenes, then just concatenate all of the clips for each scene into the final video clip, which is the final asset. And when it's stored, we can see the final result. In this case of the previous project, it's in the assembled video. That's here. Well, here, the previous one is this one. So assembled video, you can have the video file here. Okay, so this will be basically all the asset creation. And by the end, we can finalize with the SEO optimizer, which again, this is another simple agent. So it has a longer prompt, but it's also kind of simple. It should be down here. It is using Gemini Flash because it's a simple task, and it has a specific output schema, which is the video title and the video description, which is optimized for SEO and video discovery. So very simple, and this is the end of the workflow. So when it's finished, the user will have the final asset. We can see back here that the video generator is still creating. So by the logs, it's generating the videos. So we will wait. Okay, actually it just finished. Okay, so now it's just assembling the final video. So this will take maybe a few more seconds, and then we can come back to the final result. Okay, so the video was finally created. So you can see here at the logs. Okay, I had an error at the end. I think it was saving the output of the SEO optimizer. I will fix it for the final version, but you can see the output here. So the video that it suggested, the first 6 labors of Hercules, Impossible Ancient Greek Myths, quite interesting, and also a description here that I can just copy and paste as the description of the video. So you can see that it has some hashtags here to help with the video reach and discovery, and also the whole description here is optimized for this. But let's see how it looks like the final version. So I can see here the projects, Hercules Labors, the short video is the first one. So I will, yeah, it's a little bit longer than I wanted, but I think that at least for YouTube under the 3 minutes, it's still good enough. You can see that probably the reason that it took a little bit longer is that the script was still a little bit long. And looking at the scenes, how it broke down, it's not only 6 scenes. So some of the labors, it was divided into 2 scenes. But yeah, I could just iterate a little bit longer on the script, make it, just ask the LLM to make it even shorter, and it would fill the desired length. Okay, so let's play a few seconds to see how it looks like.
Driven mad by Hera, Hercules, son of Zeus, tragically killed his own family. To atone, the oracle commanded 12 impossible labors for King Eurystheus, who hoped each task would be Hercules' last. The Nemean lion, a beast with golden fur impervious to all weapons. Hercules wrestled and strangled it barehanded, then skinned it with its own claw, donning the hide as his signature armor. Eurystheus was so terrified, he hid in a bronze jar. Next, the Lernaean Hydra, a multi-headed serpent where each severed head grew 2 more. With his nephew Iolaus, Hercules cauterized each stump with firebrands, preventing regrowth. He then buried the immortal head and dipped his arrows in its venomous blood, making them deadly. Eurystheus disqualified this labor due to Iolaus's help. Labor 3.
Okay, so you can see that it looks quite good. So it intercalates the videos and images because I'm only generating a single video for each scene. So I could just generate like a bunch of videos since Veo restricts in 8 seconds for now, the longest video. I could generate only images if I wanted, since video is a little bit more expensive, so you get the idea. This is basically, I have some flexibility. Okay, so if we go back, this will be the end. So by the end, I will have the video file and also the SEO video title and description, and it finalizes the workflow creation. So it's quite good. It's very easy. Once you get the gist of ADK, it allows you to be very flexible and do a lot of things, especially with the custom agents. If you want to create very simple workflows that doesn't require a lot of logic, it's even simpler to use ADK. I also like it a lot, the integration with other Google tools like the Google search, and also implementing Gemini calls and that kind of stuff. It's quite easy. This is only local development, but if you want to deploy this to the cloud using Google Cloud Run, Agent State, Agent Space, or other tools, ADK has a very good integration with the logs so that you can visualize on the cloud, but this is only for local development. So this was the final result. I hope you enjoyed, and if you want to give it a try, just visit the GitHub repository and let me know how it goes.